What if I told you that the sun, the very source of all life on Earth, just did something so bizarre that it's left scientists scratching their heads in disbelief? The same star that lights our days, fuels our weather, and drives the seasons, has just thrown us a curveball. Something unexpected, something so puzzling that the brightest minds in astrophysics are still trying to figure it out. The sun has always been an object of fascination, and though we've learned so much over centuries, it has always managed to keep some of its deepest secrets hidden. But now, after decades of studying our closest star, something happened that has even the most experienced solar researchers asking, what just happened? So, how did the sun just break the rules? Let's dive into this shocking event that no one saw coming. Since ancient times, humans have looked to the sun for everything, from warmth to guidance, even considering it a divine symbol. But scientifically speaking, our understanding of the sun has evolved dramatically over the years. In the early 1600s, Galileo Galilei turned his telescope toward the sun, observing sunspots, dark spots on its surface. Those early discoveries were just the tip of the iceberg. It wasn't until the 20th century, when the advent of space exploration allowed us to observe the sun from afar, that we started to truly uncover its mysteries. From solar flares to coronal mass ejections, scientists have been tracking these fiery outbursts and understanding their impact on Earth. For decades, solar scientists have worked tirelessly to monitor the sun's every activity using satellites, like the Solar and Heliospheric Observatory, SOHO, and the Parker Solar Probe. They've uncovered staggering amounts of data about solar storms and sunspots, linking them to space weather and even technological disruptions here on Earth. Still, no matter how much we learn, the sun always seems to have a way of surprising us. And that's exactly what happened recently. But what's so puzzling about this latest event, you might ask? It's a discovery that's unlike anything we've ever seen before. A phenomenon that doesn't quite fit the solar behavior we thought, we understood. And no one could have predicted it. On a seemingly normal day, solar observers noticed something peculiar, something that hadn't been observed before. It wasn't just another solar flare or the typical sunspot activity that we see regularly. This event was more subtle but undeniably strange. Scientists at NASA and other space agencies around the world began detecting a highly unusual shift in the sun's behavior. Its magnetic field suddenly underwent a radical transformation, one that was totally unexpected. We know that the sun's magnetic field is a powerful force, driving solar winds and storms that affect everything from satellite communication to the Earth's magnetic field. But what these scientists saw was a complete and abrupt change, one that defied everything they thought they knew about how the sun's magnetic field operates. The sun's north and south poles, which are typically stable and follow a predictable cycle, seem to swap unexpectedly. This phenomenon is extremely rare, and to make matters even more confusing, it happened at a time when solar activity was supposed to be relatively calm. To understand why this event is so shocking, we need to take a deeper look at the sun's behavior over time. The sun operates on an 11-year cycle, known as the solar cycle, during which it experiences periods of high activity, called solar maximum, and periods of low activity, called solar minimum. During solar maximum, the sun releases massive bursts of energy in the form of solar flares and coronal mass ejections. These intense events can have a significant impact on Earth, disrupting communication systems, navigation, and even power grids. In contrast, during solar minimum, the sun's activity quiets down. However, this recent event doesn't fit neatly into any of those patterns. It's as if the sun, usually so predictable in its behavior, suddenly decided to break the rules. And when scientists observed this magnetic flip, they realized just how little they still understand about the sun's internal mechanisms. The magnetic field of the sun is not a simple, static entity. It's dynamic, constantly changing and evolving. But this sudden flip caught even the most seasoned researchers off guard. The reaction from scientists was a mixture of disbelief and awe. At first, many thought it was a glitch in the data, perhaps an anomaly caused by instrumentation error. But as more and more observations came in from various satellites and telescopes, it became clear. This was not a mistake. This was the sun, acting in a way it never had before. And that's when the questions started to pour in. How could this happen? What does this mean for our understanding of the sun's behavior? And, most importantly, what are the implications for us here on Earth? At the core of this mystery is the sun's magnetic field, which is generated by the movement of charged particles deep within its interior. The way this field flips and changes has profound effects, not just on solar activity, but also on space, weather here on Earth. Could this be a sign of an impending solar storm of unprecedented magnitude? Or is it just an isolated event, one that won't happen again for millions of years? While we don't yet fully understand the long-term consequences of this magnetic flip, we can look to the past to get some clues. Scientists are revisiting the historical records of solar activity, especially during times of solar maximum, to understand what kinds of disruptions this event could cause. Solar storms can interfere with GPS systems, communications satellites, and even the power grid, creating a cascade of technological failures that could affect everything from navigation to internet services. There's also the possibility that this magnetic flip could have an impact on the Earth's own magnetic field. The sun's magnetic field and Earth's magnetic field are connected in complex ways, and any major shift in one could cause a ripple effect. Imagine being in the middle of a solar storm. Could this newly observed behavior from the sun lead to even more intense space weather events in the future? To better understand the significance of this magnetic flip, let's dive into the science behind it. The sun's magnetic field operates in a manner quite similar to that of a giant bar magnet, but with a twist. It's constantly changing. Every 11 years, the sun undergoes a magnetic reversal, meaning the sun's north and south poles flip. This reversal is a key feature of the sun's solar cycle. It's a natural part of the sun's activity, but it usually happens in a gradual, predictable way. So why was this recent flip so surprising? It occurred far earlier than expected, and the suddenness of the event sent shock waves through the scientific community. Some researchers are now hypothesizing that this unexpected behavior could be a result of deeper, unknown processes happening inside the sun. Could this be the beginning of a new phase in the sun's life cycle, one that could have serious implications for space weather? The sun's magnetic activity plays a critical role in determining the behavior of space weather here on Earth. During solar maximum, when the sun's activity is high, we experience more frequent solar flares and coronal mass ejections, CMEs. These bursts of energy can cause geomagnetic storms that affect everything from power lines to satellite communication. And, while we've always known about the connection between the sun's activity and space weather, this latest discovery hints at even deeper connections, ones we've yet to fully understand. One of the most important questions that researchers are grappling with is whether we're prepared for the potential consequences of this event. Scientists are working on models to predict how this sudden change in the sun's behavior could impact us, but the truth is, there's still a lot we don't know. We may have to rethink our approach to space weather forecasting, ensuring that we have the tools and infrastructure in place to respond to solar events that could be more unpredictable than we once thought. The sun is much more than just a fiery ball in the sky. It's the heart of our solar system, the source of life on Earth, and the driver of our climate and weather systems. Without the sun, life as we know it simply wouldn't exist. But despite its importance, the sun is still an object of mystery and fascination for scientists. The sun is located about 93 million miles from Earth, and it's primarily made of hydrogen, about 75%, and helium, around 24%, with small amounts of other elements like oxygen, carbon, neon, and iron. Its incredible heat and energy come from the process of nuclear fusion happening in its core, where hydrogen atoms are fused together to form helium, releasing an immense amount of energy in the process. This energy travels outward from the core, radiating across space and providing the warmth and light that sustain life on our planet. This process has been going on for about 4.6 billion years, ever since the sun formed from a cloud of gas and dust. The sun has been in a relatively stable phase, known as the main sequence, for most of its life. However, it's far from static. It's constantly evolving and undergoing subtle shifts that scientists are still trying to fully understand. For many years, scientists have been studying the sun's behavior in the context of an 11-year cycle, known as the solar cycle. During this cycle, the sun's magnetic field undergoes a reversal, with the north and south poles swapping places. This cycle is marked by periods of solar maximum, when the sun's activity is at its peak, and solar minimum, when it is calmer. These phases are characterized by an increase or decrease in solar flares, sunspots, and coronal mass ejections, CMEs, massive bursts of solar wind and magnetic fields that can reach Earth and affect space weather. During solar maximum, the sun is at its most active, with more sunspots and solar flares. These eruptions can have a dramatic impact on Earth, potentially causing disruptions to satellite communications, power grids, and GPS systems. On the other hand, during solar minimum, the sun is quieter, with fewer sunspots and solar flares and less intense space weather. This cycle has been observed for centuries, with early astronomers like Galileo and sunspot pioneer Heinrich Schwabe noting the regular fluctuations in the sun's behavior. For decades, scientists have relied on the solar cycle to predict the sun's activity and its impact on Earth. It's been a useful framework for understanding how the sun behaves, but the event we're discussing today has thrown a wrench into the predictability of this cycle. The sun's magnetic field is a powerful, dynamic force. It's created by the movement of charged particles within the sun's core, and it affects everything from the sun's eruptions to the way solar wind interacts with Earth's magnetosphere. The magnetic field lines twist and turn in complex ways, creating phenomena like sunspots and solar flares. At the core of the sun, nuclear fusion produces immense amounts of energy. This energy causes convection currents, which stir up charged particles within the sun. As these particles move, they generate magnetic fields, which become tangled and twisted. This tangled magnetic field leads to the creation of sunspots, regions of intense magnetic activity that are cooler than the surrounding solar surface. When these magnetic fields become unstable, they can release massive bursts of energy in the form of solar flares or coronal mass ejections. These events can send high-energy particles toward Earth, causing geomagnetic storms that can disrupt communication systems, power grids, and even astronauts aboard space missions. But this magnetic field doesn't just stay the same, it changes. Over time, every 11 years, the sun's magnetic field reverses. The sun's north and south magnetic poles switch places, and the sun enters a new phase of activity. This reversal is one of the most fascinating aspects of the sun's behavior. But what we've witnessed recently is a completely different kind of reversal, one that has left scientists perplexed. Solar scientists have long been aware that the Sun's magnetic field flips every 11 years. This flipping of the poles is part of the natural solar cycle, and it has been observed for centuries. However, what recently caught the attention of scientists was something entirely different. A sudden, unexpected change in the Sun's magnetic field that didn't fit within the typical solar cycle. This unusual event is so perplexing that scientists are still trying to understand it. The Sun's magnetic field is generated by the movement of plasma within the Sun's core, and it's responsible for many of the solar phenomena we observe, such as sunspots, solar flares, and coronal mass ejections. But recently, this magnetic field underwent an abrupt change, one that wasn't part of the expected 11-year cycle. Instead of following the gradual process of solar maximum and minimum, the Sun's poles seemed to flip suddenly and unpredictably. This shift in the Sun's behavior was first noticed by scientists monitoring the Sun's magnetic field using advanced instruments like the Solar Dynamics Observatory, SDO, and the Parker Solar Probe. These instruments measure the Sun's magnetic field, sunspots, and solar activity, providing valuable data about how the Sun behaves over time. The unexpected reversal occurred without the gradual buildup that usually marks the transition from solar maximum to solar minimum. Instead, it was a sudden and sharp change, leaving researchers with more questions than answers. The Sun's magnetic activity has a direct impact on space weather, which in turn affects us here on Earth. Solar flares and coronal mass ejections can disrupt communication systems, damage satellites, and even interfere with power grids. The Earth's magnetic field protects us from the most harmful effects of solar storms, but strong solar activity can still cause disruptions. In extreme cases, a large-scale solar event could have catastrophic effects on Earth's infrastructure. The Sun's recent magnetic flip raises several important questions about the future of space weather. Could this unexpected reversal lead to more frequent or more intense solar storms? Could we be entering a new phase in the Sun's activity that will have a more significant impact on Earth? And, more importantly, are we prepared for the potential consequences? The key to understanding this magnetic flip lies in understanding the Sun's internal workings. Scientists have long believed that the Sun's magnetic field reverses in a predictable manner, following the 11-year solar cycle. But this recent event challenges that understanding. Could it be a sign of deeper, more complex processes happening inside the Sun? One possibility is that the Sun's core, which generates the magnetic field, is experiencing changes that we can't yet observe. The Sun's core is incredibly difficult to study directly, as it is surrounded by layers of gas and plasma. However, scientists use a technique called helioseismology to study the Sun's interior by observing the vibrations on its surface. These vibrations can reveal information about the Sun's structure and dynamics. Recent studies using this technique have suggested that the Sun's internal dynamics may be more complex than previously thought. Some scientists are now exploring the possibility that the Sun's magnetic field may be influenced by factors such as the rotation of the Sun's core or the movement of different layers of plasma. If this is the case, it could mean that the Sun's behavior is much less predictable than we once believed. The Sun's magnetic activity also affects Earth's magnetosphere, the protective magnetic shield that surrounds our planet. This shield deflects harmful solar particles, protecting us from radiation. However, when the Sun's activity increases, such as during a solar maximum, these solar winds can overwhelm the magnetosphere, causing geomagnetic storms. Geomagnetic storms can disrupt communication systems, GPS signals, and even power grids. In extreme cases, they can even endanger astronauts in space by increasing their exposure to radiation. The recent changes in the Sun's magnetic field could lead to more intense space weather, potentially creating new challenges for space exploration and the technology we rely on here on Earth. As scientists continue to study this unexpected event, one thing is clear. The Sun is more complex and mysterious than we ever imagined. This recent magnetic flip could be a sign of a new phase in the Sun's behavior, one that we may not be fully prepared for. With the Sun's impact on space weather and our daily lives, it's essential that we continue to monitor and study the Sun's activity. The more we learn about our closest star, the better equipped we'll be to face the challenges of the future. This event serves as a reminder that the Sun is not just a predictable, stable force in the sky. It's a dynamic, evolving entity that continues to surprise us with its power and complexity. Scientists may still be puzzled by this latest discovery, but one thing is certain. The Sun is far from boring. It's a force of nature that we are only just beginning to fully understand. And each new revelation brings us one step closer to unlocking the mysteries of the universe. While the Sun's recent magnetic flip has left us with more questions than answers, it's far from the only mystery we're trying to solve. It's to have a way of surprising us. And that's exactly what happened recently. But what's so puzzling about this latest event, you might ask? As we learn more about the Sun's internal mechanics and its impact on our solar system, we continue to confront unresolved questions that challenge even the most well-established theories. For instance, one major enigma is how exactly the Sun's magnetic field is generated. Scientists have long understood that the Sun's core and outer layers of plasma play a role in generating its magnetic field, but the exact mechanisms remain unclear. The Sun's magnetic field doesn't behave like the field of a typical magnet. Its behavior is far more complex, shifting and changing in ways we can't fully predict. Understanding the intricacies of this magnetic field is essential, as it influences everything from solar flares to the space weather that affects Earth's infrastructure. But despite the progress we've made, the inner workings of the Sun's dynamo, its engine for generating magnetic fields, remain elusive. Another long-standing mystery is the nature of the Sun's corona, the outermost layer of its atmosphere. During solar eclipses, we can observe this glowing halo around the Sun, but we still don't know why the corona is hotter than the Sun's surface. The corona is millions of degrees hotter than the Sun's surface, which defies our basic understanding of how heat and energy should flow. It's as if the Sun's outer atmosphere is doing the opposite of what we'd expect. Its temperature increases the further you go from its core. Scientists are still searching for the exact cause of this phenomenon, and it remains one of the most perplexing mysteries in solar physics. Then, there's the question of solar wind. The Sun's solar wind, a stream of charged particles ejected from the Sun's upper atmosphere, flows outward into space, impacting planets and their magnetospheres, including Earth's. But scientists don't fully understand how the solar wind accelerates to the speeds we observe. While we know that the Sun's magnetic field plays a role, the detailed process behind the acceleration of solar wind is still an enigma. In addition to these long-standing mysteries, recent discoveries have raised new questions about the Sun's behavior. The unexpected magnetic flip that scientists observed recently has left researchers wondering if we're seeing the early stages of a larger, unknown shift in the Sun's activity. The abruptness of this change suggests that something fundamental about the Sun is evolving in a way that we don't yet understand. The most pressing question right now is, why did the Sun's magnetic field flip so unexpectedly? Scientists have spent decades studying the Sun's behavior, and while magnetic flips are part of the solar cycle, this latest event doesn't seem to fit the pattern. The 11-year solar cycle is usually predictable, with gradual shifts in the Sun's activity, but this sudden flip has many researchers scratching their heads. Could it be a sign of something much larger happening inside the Sun? Or is it simply an anomaly? A one-off event that won't happen again? Some scientists speculate that this sudden flip could be the result of unknown forces deep within the Sun. The Sun's core, where nuclear fusion occurs, is still largely a mystery, and it's possible that changes within the core are causing these unexpected shifts in the Sun's magnetic behavior. Others believe that this anomaly might be tied to the Sun's natural cycle, which could be behaving in ways we don't yet fully understand. While the magnetic flip is certainly an attention-grabbing event, it's only one piece of the puzzle. There are countless other aspects of the Sun's behavior that continue to defy explanation, leaving scientists with more questions than answers. The most shocking discovery to emerge from this unexpected magnetic flip is the possibility that we may be witnessing the beginning of a new phase in the Sun's life cycle, one that could have profound implications for Earth and beyond. What if this event signals the start of a more dramatic shift in solar activity? Could the Sun be entering a period of heightened instability, one that might lead to more frequent and intense solar storms, stronger coronal mass ejections, and a greater impact on our planet's technological infrastructure? Imagine this. For years, scientists have been predicting a solar maximum, a time when the Sun's activity would reach its peak. Solar storms and solar flares are a regular occurrence during this phase. But if the Sun's magnetic behavior is undergoing a shift that's more abrupt than expected, could this signify an even more intense solar maximum? What if the Sun is no longer adhering to the predictable patterns we've relied on for centuries? The implications of such a shift could be far-reaching, affecting everything from satellite communication to global power grids. Here's the most dramatic part of this revelation. Some researchers are now considering the possibility that this sudden magnetic flip could be an early warning of a much larger, more unpredictable solar event. In the past, solar researchers have linked large-scale solar storms to sudden shifts in the Sun's magnetic field, and there's speculation that this unexpected flip could be an indication that the Sun is about to unleash even more powerful forces than we've seen in the past. For years, we've known that solar storms can disrupt communications, navigation systems, and even cause blackouts. But what if the Sun is capable of producing storms that are far more intense than anything we've experienced? The thought of such a possibility is both thrilling and terrifying. Could we be on the brink of a new era of solar activity, one that's unlike anything we've ever witnessed before? Could this sudden flip in the Sun's magnetic field be a warning sign of even more dramatic solar events? If so, what should we expect? Will the Sun begin to release massive bursts of energy, triggering geomagnetic storms that affect not just communications and GPS systems, but also global power grids? The potential for disruption is immense. In some ways, this is a wake-up call. As our reliance on technology increases, our vulnerability to solar storms becomes more pronounced. We live in a world that's more connected than ever, with satellites and communication networks linking us across the globe. But as solar activity becomes more unpredictable, we may find ourselves exposed to risks we never imagined. And the most alarming part? We still don't fully understand the Sun's behavior. While we've made great strides in solar research, the Sun is still holding many of its secrets close to the chest. Each new discovery brings us closer to unlocking those mysteries, but the Sun's true nature is still elusive. In the end, this unexpected magnetic flip might just be the beginning of a series of discoveries that will redefine our understanding of the Sun. It could mark the start of a new phase in solar activity, one that brings both new challenges and new opportunities. But one thing is for sure. The Sun is far from predictable, and the mysteries surrounding it will continue to captivate scientists for years to come. Will we be prepared for the next shocking discovery? Only time will tell. So, what just happened? With the Sun? In the world of solar science, this unexpected magnetic flip has left scientists stunned and intrigued.